Good day, everyone. Welcome to Simplify Chemistry channel, where we learn chemistry with simple method. And I believe at the end of this class today, you are going to enjoy it. Please don't forget to subscribe, like, and share our video. Chemical reaction, that's what we are going to be dealing with today. Chemical reactions. After we've learned a series of formulas, we want to see chemical reaction. Before a chemical reaction could happen, there must be a reactant to give us products. What are reactants? Reactants are the substance or substances that are going to undergo the chemical processes. What are products? Products are the new substance formed as a result of the chemical reaction. I repeat, they are the new substances formed as a result of chemical reaction. We have many types of reactions, name it, many. But in this class, we are going to be talking about few. We have combination reaction, decomposition reaction, displacement reaction, thermal dissociation, catalytic reaction, and so many, name it. Oxidation and reduction, redox reaction, and so on. But for the purpose of this class today, we are going to be talking about this. Let's start. What is chemical reaction? We said, by definition, chemical reaction are changes in which some new substances are formed. Are changes in which some new substances are formed. And we said there must be reactants and products. Like I said earlier, the reactants are the one that undergoes the new changes, and products are the substances that form. Let's see example when we say a reaction is a combination reaction. Example, combination reaction. Combination reaction. From the word combination, combine, where two or more combine to form a single compound. They combine. Two or more combine. We can have a simple element. Let's use it this way. Let's say elements plus elements to give us compound. Element plus element to give us compound. We can also have a bigger compound by a compound plus compound to give us a bigger compound. Now, let's see example. Elements combining with an element. Let's see example. Let's see iron plus sulfur to give us iron 2 sulfide. It's an example of combination reaction. You can see an element to give us a compound. Let's see example of a compound combining together. Lead 2 oxide plus sulfur 4 oxide to give us lead tetrahydrosulfate 6. Lead 2 tetrahydrosulfate 6. Compound plus compound to give us a bigger compound. Note, keyword, they form a single compound. They form a single compound. Now, let's see another example. Decomposition. 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 Decomposition reaction. From the word decompose. What do you think the word decompose means? That's splitting down of a compound into smaller ones, splitting down of a compound into smaller one. So it can be into 2 or more. So it's split up. So we have different types of processes that a compound can be decomposed. It can be through a thermal decomposition. It can be through a thermal decomposition. A thermal decomposition. How do I mean? Thermal decomposition, that's application of heat from the word thermal. Let's see example of a thermal decomposition. Let 2-trial-2-nitrate-5 split down with the application of heat to give us splitting up, thermal decomposition. We also have displacement reaction. We have displacement reaction. Displacement reaction is another type of a reaction. Displacement. From the word displaced, this is when the ion or the metal that is higher in the ECS, that's electrochemical series, displace the lower metal from its solution or from its compound. It will replace it from its compound, displace it from its compound. Displacement reaction. So it's exchange of the radicals to form, it's exchange it to form another one. Let's see example. A plus BY. This will remove this from A, so that B will be on its own and A replacing it. That's an example. Let's say example, zinc plus copper sulfate. Because zinc is higher than copper, it will displace it from here to form zinc sulfate plus copper displacement. So zinc has displaced copper out of its solution. 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 We also have thermal dissociation. Thermal dissociation. Dissociation is different from decomposition. Please let us take note. Dissociation is different from decomposition. This dissociation, anything that dissociates does not dissolve. It will not dissolve. It is insoluble. So thermal dissociation, by the use of heat to split the molecule into 2 or more. Into 2 or more. Let's see. Thermal dissociation. Thermal dissociation. Example, application of heat. Ammonium chloride. When you heat up, it gives you ammonia plus hydrogen chloride. This is a reversible reaction, which means if you cool it back, you have your ammonium back. If you cool it back, you have your ammonium back. We also have, let's see, dioxonitrogen 4. Application of heat gives you nitrogen 4. If you cool it down, then the reaction reverse. Then the last type of reaction we are going to be talking about here is catalytic reaction. Catalytic reaction. What is catalytic reaction? So catalytic reaction is a reaction that involves the use of catalyst. It's a reaction that involves the use of catalyst. What is catalyst? Catalysts are substances that speed up a rate of chemical reaction, and at the end of reaction, itself it's not being used up. Take notes. Itself it's not being used up. Catalysts, they speed up the rate of reaction. They save time for the reaction to complete. Catalyst does not take part in that reaction, it only speed up. So at the end of the reaction, this catalyst does not lose weight or quantity. So you must know, catalyst affects a reaction in two ways or in two phases. So we have the homogeneous catalyst and the heterogeneous catalyst. We have the homogeneous catalyst and the heterogeneous catalyst. What are the characteristics of a good catalyst? Take notes. Catalyst, what I said, they alters the rate of a reaction and itself is not being used up. Number two, catalysts are specific in their reaction. Catalysts are specific. They know this is where we are going, this is what we want to attain. Catalysts are specific in their reaction. They will ask you, or they may ask you in an exam, what are the functions of catalyst? What are the characteristics of a catalyst? A catalyst, what? They are specific in their reaction. These are some of the reactions that we are going to be discussing in this episode of teaching. I believe that you enjoyed our class for today. Please don't forget to like our video and subscribe. Thank you.